Today we are going to discussing about concurrent lines. Before that, you know about intersecting lines. Once I will revise that one. Intersecting lines. Let us take a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. These are the two lines. If these are intersecting means they have the that means these two lines passing through a fixed point. Okay, so then these two lines are called intersecting lines. How can you find out the intersecting of two lines? You know in 10th class. So we can by eliminating method, substitution method, okay, or cross multiplication method. Whatever maybe you take. Okay, if you go for cross multiplication method, so you have to take here x, y, 1 for constants, x for x here, x, y, and for constants you have to take 1 and start from the coefficient of y. So we have to here we have 4 regions 1, 2, 3, 4. These 4 regions how you means you have to start from b1, that means coefficient of y, b1, c1, a1, and again stop with b1. See here b1, c1, a1, b1, and the same for second equation also. B2, C2, A2 and B2. So you have to write x by cross multiplication of these two. Cross multiplication means always you have to start from here only. Don't come here. Or don't take multiplication of these two first. So we have to take first these two only. So B1 C2 minus B2 C1 is equal to y by C1 A2. These two cross multiplication minus C2 A1 is equal to 1 by A1 B2 minus a2 b1. If you want to find out the x value, equate these two. If you want to find out the y value, equate these two. So x is equal to what here? So b1 c2 minus b2 c1 by a1 b2 minus a2 b1. Okay. So I am writing total x come out. So y is equal to c1 a2 minus c2 a1 by a1 b2 minus a2 b1. This is the point of intersection of these two lines. Okay, next concurrent lines. This is very, very important. Concurrent lines. Okay. If two lines passing through a fixed point, then these two lines are intersecting lines, and this is called point of intersection. If three or more than three lines passing through a fixed point, that means all these have one common point. Okay, then those lines are called concurrent lines, and this point is called point of concurrence. Point of concurrence. Okay, see here, if you have three lines are concurrent. If a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, a3x plus b3y plus c3 is equal to 0 are said to be concurrent, if determinants already be completed, if determinant of a1, b1, c1, a2, b2, c2, a3, b3, c3 is equal to 0. If any new students are there, once you go to matrices topic and see that how to find out the determinant. Okay. So it is three lines. If these three lines are concurrent, if we are concurrent, if and only a1, b1, c1, a2, b2, c2, a3, b3, c3 is equal to 0. Determinant of. Let us denote this one. First line is L1, second line L2, third line L3. Then otherwise we can say same for concurrent. We can use this formula or next what I am saying that one. So are concurrent, then lambda 1 L1 plus lambda 2 L2 plus lambda 3 L3 is equal to 0. That means just you take some real constants where lambda 1, lambda 2, lambda 3 belongs to real number. By multiplying something to L1, multiplying something to L2, multiplying something to L3, and add them, these three will be 0. Sum of these three will be 0. Then also we can say these three lines are concurrent lines. Okay. See one more thing. The form of the line. The form of the line which is passing through point of intersection of lambda 1, sorry, some L1 and L2. This is the line. L1 is equal to 0, L2 is equal to 0. The form of the line, we are going to find in the form of the line which is passing through point of intersection of L1 is equal to 0 and L2 is equal to 0. That means this is L1 is equal to 0, L2 is equal to 0. Now we want to find out the L3 is equal to 0. Third line, which is passing through point of intersection of these two lines. Then what can you say? This L1, L2, L3, all these three are concurrent lines. I am writing here. See, L1 is equal to 0, L2 is equal to 0. Okay, our third line is passing through this point of intersection means these three lines are concurrent. Okay, the form of the line which is passing through point of intersection of L1 is equal to 0, L2 is equal to 0 is L3 is as we can write as lambda 1 L1 plus lambda 2 L2 is equal to 0. In other words, if you divide this lambda entire equation, L1 plus lambda 2 by lambda 1 into L2 is equal to 0. That means we can say some L1 plus some lambda L2 is equal to 0, where lambda is equal to lambda 2 by lambda 1. Okay, so that means we want to find out the any line which is passing through the point of intersection of given two lines is nothing but, for suppose those two lines are L1 is equal to 0, L2 is equal to 0, then that third line which is passing through the point of intersection of given line, that means those three lines are concurrent lines such that the third line is nothing but L1 plus lambda L2 is equal to 0. Okay, you can write this formula you can use or this formula you can use. Any one of the formula you can use to find out the third line. And we can say here lambda is any parameter. Parameter means real number. Once you come to point, different values of lambda. For suppose L1 plus lambda L2 is equal to 0. If you take this is the any line. This line is always passing through the point of intersection of L1 is equal to 0, L2 is equal to 0. This is nothing but L1 plus lambda L2 is equal to 0. Here lambda belongs to R. That means lambda belongs to R means we can take infinitely many real numbers instead of lambda. That means we can get infinitely many lines we can find. Infinitely many lines means all those lines are passing through this point of intersection. That means all those lines, this L1 plus lambda L2 represents the family of concurrent lines passing through the point of intersection of L1 and L2. This is very important because in the place of lambda you can take 1, 2, 3, 4. By taking 1, 2, 3, 4, 1.1, 1.2, 1.3, root 1, root 2, root 3, whatever may be all real numbers and all real numbers if you take instead of lambda. So you get infinitely many lines. All those lines are passing through point of intersection of these two lines L1 and L2. And all those lines are nothing but concurrent lines. So this represents the family of concurrent lines passing through the point of intersection of L1 is equal to 0 and L2 is equal to 0. Whenever if you have the equation in this form, this form, whenever the line equation is in this form, L1 is one line, L2 is another line. That means if you take one example, a1x plus b1y plus c1 plus some lambda into a2x plus b2y plus c2 is equal to 0. That means this represents the family of concurrent lines passing through the point of intersection of these two lines. That means if you want to find out if it represents the family of concurrent lines, then find the point of concurrence means that point of concurrence is nothing but point of intersection of these two lines. See, so let us take this is a1x plus b1y plus c1 is equal to 0. This is a2x plus b2y plus c2 is equal to 0. Let us take. Okay, so this line is passing through this point. Okay, this is nothing but L1x, this is a1x plus b1y plus c1 plus lambda into a2x plus b2y plus c2 is equal to 0. This is the line. So, this is a line means here different values of lambda we can take different lines passing through this point. So then what can we say? All these lines are nothing but a family of concurrent lines. And if you want to find out the point of concurrence, that point of concurrence is nothing but point of intersection of this line and this line. That is nothing but point of intersection of these two lines only. So whenever you want to find out the point of concurrence, then you take this line and this line and find out the point of intersection by using Cramer's method or elimination method or substitution method. Any method you can follow. See here, you take one example. If LA plus MB plus MC is equal to 0, then prove that AX plus BY plus C is equal to 0 represents set of concurrent lines and find the point of concurrence. See here, by using this condition, we have to prove this line AX plus BY plus C is equal to 0 represents set of concurrent lines. Represent set of concurrent lines if you want to show this one by using this condition. This one we have to write in the form of something plus lambda into something is equal to 0. Here lambda means any value you can take, any constant. And you understand, whenever AX plus BY plus C is equal to 0, here A, B, C belongs to real numbers, those are constants only. Here X, Y are the variables. So here this one in terms of variables, this one in terms of variables, this lambda should be purely real number, then this one represents a set of concurrent lines or family of concurrent lines. Okay, see here what is given, LA plus MB plus MC is equal to 0, and here we have AX plus BY plus C is equal to 0. Okay, you can write either A or B or C converter. Okay, you have to make this one any A or B or C, make subject. Here I am making A as subject. So LA is equal to minus MB minus MC. So A is equal to what I write, minus M by L into B minus M by L into C. This one you take 1. Substitute 1 in AX plus BY plus C is equal to 0. Okay, substitute 1 in AX plus BY plus C is equal to 0. Then what you have here, A means minus M by L into B minus M by L into C of X plus BY plus C is equal to 0. Now you separate X terms, A terms and B terms separately. Okay, B terms and C terms separately. Here there is no A, so B comma C separately. Okay, that means first you multiply minus M by L Bx minus n by L Cx plus By plus C is equal to 0. So you take here B common, what you have? If you take B common, minus m by Lx plus y. If you take C common, either plus C or minus C, I am taking plus C here. So what you have? Minus n by Lx plus 1 is equal to 0. It is in the form of what it is? Some ax plus by plus c is equal to 0. C means here 0. There is no constant. Here it is also in the form of some ax plus by. Here b is 0 because y term not there, not present. Here not presented. So b term is 0. So my n by L x plus 1 is equal to 0. And you entire equation if you divide with b, then what you have? Minus m by Lx plus y is equal to c by plus c by b into minus L by n by Lx plus 1 is equal to 0. So this is the one equation, L1 is equal to 0. This is another equation, L2 is equal to 0. This is some lambda. So it is in the form of L1 plus lambda L2 is equal to 0. So what can you say? It represents set of concurrent lines.